Question 5. A sample of ethane dioic acid was treated with an excess of an unknown alcohol in the presence of a strong acid catalyst. Well, a carboxylic acid group, COOH group, and an alcohol, OH, you will know make water, and that's what the strong acid catalyst does. The sulfuric acid helps to remove that water, and it will make an ester, a C double bond OO link. So the alcohol could react with the dioic acid on one end, or the alcohol could react with the carboxylic acid group not just on one end but on the other end as well. So that's why you could get two different products. If the alcohol reacts with just one end, you'll get one product. If it reacts with both ends, you'll get two products, a different product. So the product's reaction was separated and analysed in a time-of-flight mass spectrometer. It measures the mass of the products that are made. Two peaks were observed, one at mass divided by charge ratio 104 and one at 118. Now these are the MRs. Assuming the charge on the ion is 1 plus, these are the masses, these are the MRs of the two molecules. I'm guessing that this one will be if an alcohol reacts with one carboxylic acid group on one end, and if the alcohol reacts with both carboxylic acid groups to make an ester at either end, then it will make a slightly larger molecule. So let's have a little think. So what kind of alcohol am we going to make? 104 and 118. Well, the ethane dioic acid from the previous question, we know it's going to react with an alcohol to make an ester, and we know that ethane dioic acid is H2C2O4. Now, H2C2O4 is 2 1s for the hydrogens, 2 12s for the carbons, and 4 16s for the oxygen. It's got an MR of 90. So if the alcohol adds on and makes 104, it will release a little bit of water, but if it makes 104 and we've already got 90 from the ethane dioic acid, that doesn't leave a lot of mass for the alcohol. So I'm going to guess that it's methanol, and I guess that it's a very small alcohol because we've not got much MR left if we're going to get up to 104 from 90. So the methanol can react with one COOH group. We'll check out that it's 104 in a minute. We've got ethane dioic acid and the methanol. The OH on the carboxylic acid group reacts with the H on the alcohol, and it's going to make HOOCCO, and then the OH is gone, and it reacts with that, joins on with that OCH3. So it's going to make that ester there, and water is released. So that ester there, with that OH gone from the carboxylic acid, and the H there, and the O bonds then onto the CO. So I've got C double bond O, OCH3 is my ester. Let's just check out what I've got. I've got 4 hydrogens, which is 4. I've got 3 carbons, which is 36, and I've got 4 oxygens, which is 64. That adds up to 104. So it was methanol. And then for my 118, it will react with both ends. So 2 lots of methanol. So at one end it loses an OH, and a methanol joins on, loses an H, and forms an ester at one end, and it will form an ester at the other end. And if I add the MR up of that, it will equal 118. Now, in a mass spectrometer, what you do is you fire an electron gun, you use an electron gun to fire an electron onto this, and it will knock off another electron and leave this plus charged. So that's the ion that will be made in the mass spectrometer and will be accelerated along the tube. And we've got this ion then mass 104 and this ion mass 118. Since they've got a charge of 1 each, m divided by z, the mass divided by the charge, z is the charge, 1 equals 104 and 118. Outline how the time-of-flight mass spectrometer is able to separate these two species to give two different peaks. So it's because they've got different masses, and what actually happens is in the time-of-flight mass spectrometer, they've both got the same kinetic energy. So both of these molecules have the same kinetic energy, but because this one is smaller, and they both got the same kinetic energy, this one gets accelerated towards the plate more quickly, and moves at a faster speed, gets accelerated more quickly, moves at a faster speed and hits the detector plate before this one, and that's why you can distinguish between the two. So the positive ions, these plus ions, are accelerated by an electric field to a constant kinetic energy, so they've both got the same kinetic energy. The positive ions, both 104 and 108, have the same kinetic energy, but the ones at 104, mass 104, because they're smaller, move faster, and therefore the ion, the 104 ion, this ion, arrives at the detector before this ion, mass 118.